Well, hi everybody. My name's Gavin. At the day job, I help people with software delivery and infrastructure delivery and that stuff. But this evening, I wanted to talk about the kind of separate but related topic of how advancements in this area, in particular this business of infrastructure automation and infrastructure as code, affect the working practices and working lives of the people and teams that use them. In particular, those teams we call IT operations or infrastructure or network services or names like that. So there are some companies that like to think of themselves as being born in the cloud. And these are the companies that have never had to deal with provisioning infrastructure of any kind. So every line of code they write is focused on delivering features and delivering value to their customers. And, quite commonly, the entire tech stack just consists of Firebase or Heroku or something like that. And they think that Helm is how you steer the yacht you bought with the investor's money. And these are the companies that are doing no ops, so to speak. And if this describes you or this describes your company, you can hang up for a while now, maybe check out EastEnders, come back to the open space. But assuming there are some people still watching, let's think about a different group of companies who have what we might call a classic IT organization with dev and ops and QA and security and so on, organized into silos or stovepipes or some other metaphor. And I like this particular picture of the silos. As you can see, they're fed from the top and all the actual work takes place at the bottom. But these organizations are characterized by expensive handoffs between the silos, such as the handover to support meeting. My early career wasn't really very enterprisey, so the first time I came across this acronym, it took me ages to figure out what it stood for. HOTS meeting. So these handoffs are frequently focused on what's called artifacts, which are documents, such as those Excel spreadsheets that contain a list of all the steps that we have to do a software release or an upgrade, and which team has to do each step, and then we get a little box to fill in or sign off when our step is done, and then we store the spreadsheet in the team site because governance. And in the past, I think a lot of the modernization effort in these organizations, which was called industrialization of software delivery, was focused on optimizing these handoffs rather than figuring out why we were doing them in the first place. And these are the companies who think that Lambda is the forbidden dance from Brazil. Now, in real life, of course, almost no company fits neatly into either of these two categories, but rather there's a continuum of, let's say, delivery automation with companies and technology organizations distributed all the way along. And for the benefit of those participants who are too young to remember the time before coronavirus, these little pictures here, these were called offices. And they were big buildings with lots of lifts and terrible coffee where people went to sit around wearing these expensive noise-cancelling headphones and writing nasty things about each other on Slack. Now, it's a goal of many organizations, particularly those where the CEO has read maybe even past the first 20 pages of the Accelerate book, to move towards the right-hand end of this continuum, towards the unicorn end. But how do we get there? Well, in DevOps circles, there's a lot of talk about bridging the gap between development and operations. In fact, I did a Google search earlier for DevOps and bridging the gap, and this returns over 100,000 results. So clearly it's quite a big deal. Now, the promise is that as long as we can assemble the right collection of tools, the gap will be bridged and we'll be on the road to Unicorn Central. I'm not sure if you're familiar with this page from Zebia's website. I have kind of a love-hate relationship with it. On the one hand, you can click on a few of these boxes on the left here and then invoice the client 20 grand for the DevOps transformation roadmap. But on the other hand, some companies get the idea that the more of these boxes you click, the more DevOps you'll be able to do. And I'm sure many of us have had a similar experience. There's one place I worked where I think they may have had every single tool on the left here, and we don't need to talk about how that turned out. But what's missing from this picture, of course, is the people who are going to operate those tools to build those bridges. And for many years, the technology organizations of large companies were organized more or less like this, with the pointy-haired boss at the top, in charge of a team of heads of, each with their own supporting cast of underlings. And you can see that this diagram is of an organization that's already on that DevOps journey, because the testers are now called exploratory testers instead of manual testers, and they've recruited a test automation developer. I mean, just the one test automation developer, because you can only really rely on manual testing. And there's also a principal Scrum Master and a team of Scrum Masters and assistant Scrum Masters. And there's a senior lead developer and a lead developer and some senior developers and some full stack developers to actually do the website. Right? we can see that the ops division is pretty unreconstructed. And a lot of the people here have fairly specialized skills, DBAs and network analysts and senior network analysts and security engineers and security analysts and so on. And the natural next step for organizations at this stage of development is to establish a DevOps Center of Excellence, which represents a radical realignment of the organizational structure. So the head of ops is now called the head of DevOps, and a few new people have joined the DevOps Center of Excellence. These include that test automation developer from earlier. I mean, he wasn't really getting on very well with the other testers, and writing those test harnesses was taking ages compared to clicking around on the website. There are also a couple of full stack developers to help with automation and source control and so on, and a Scrum Master and an Assistant Scrum Master to help the DevOps team with estimating tasks and stories and calculating capacity and velocity and other vital DevOps activities. In the post-GDPR world, it's good news for the security team, who are now so important that they sit entirely outside the Dev and DevOps organizations. So what's wrong with this picture? Well, it's uncontroversial now, I think, to suggest that nothing's really changed other than a few job titles. And we still have developers who can write code and throw it over the fence and to be maintained and supported by the DevOps, formerly Ops team. And the most extreme example of this I've seen was a DevOps Center of Excellence, and I think it was called that, being provided by a third party, and it was located in different time zones of the developers. And all the communication between the developers and the DevOpsers was by service request ticket, and this was to make sure that the DevOps Center of Excellence didn't do any out of scope DevOps. And yes, indeed, there was someone checking that none of these service requests between the developers and the DevOpsers were out of the scope of the service agreement. What's the real point? Well, I think that all of this talk about bridge building and cross collaboration and indeed DevOpsing comes down to this: that somehow our organizational designs fail to align the incentives or the motivations of these two groups. We know how this goes. The developers are supposed to have their features or their release delivered by date X, and for whatever reason, it doesn't happen. So the developers say, well, the database wasn't provisioned in time, or we had these firewall problems during the release, or the ACLs were wrong on the network share. And what do we say to the developers? We say, well, what's all this blame game? That's not very agile, is it? And then when the release does get shipped, and the DevOps team say, oh, it's a nightmare to support. It writes 100,000 log records every second, and the CPUs are all maxed. We say, now, hang on a minute. I thought you were supposed to be embracing the collaborative future. That's a DevOps detention for you lot. And remember the silos. This culture comes from the top. So what's the effect of all this behavior? Well, it turns out that Ansible, at least by itself, can't resolve these misaligned motivations. So the age-old conflict continues. The DevOps team carry on thinking the developers are a load of cowboys who don't care about security and don't care about stability. And the developers think of the DevOps team are a load of dinosaurs who are only there to slow them down. And in my experience, in many organizations, often they're both right. So what to do? Well, in many organizations, what happens next is that we dismantle the DevOps Center of Excellence and embed the DevOps excellence in each of the teams. And this is commonly justified because, Facebook do it or Spotify do it. And I think this often forgets that it is possible there are some other relevant differences between Facebook's business and our business, or Spotify's business and our business. But anyway, we get some new job titles, which, because agile, we let them choose themselves. And each development team gets its own DevOps engineer. Now, there are some definite advantages to this arrangement over the previous one. I mean, you'd hope there's greatly reduced communication overhead between the developers and the DevOps engineers, and hopefully it doesn't need to be mediated by service requests. And one thing you'll notice is that the DevOps engineers have a distinct management and reporting structure. And this is very common, and it comes from this idea that, the software managers don't understand the DevOps people, so they can't provide effective management and vice versa. And there's no way a software organization can provide a career structure for an ops person and vice versa. And that's where this kind of matrix management comes from. But what it really does is it goes to reinforce the message that the DevOps people are somehow special or different. And all of that leads to this. Instead of developers throwing code over the fence into the next field, they throw it into the DevOps corral in the corner of their own field. And ultimately, deployability and operability and the other realities remain not really a concern for the feature developers, and feature delivery remains not really a concern for the DevOps Jedi, who are maybe not even operating on the same cadence. And it strikes me that this pattern here is like a fractal of the larger siloed organization design, and like any fractal, it exhibits similar characteristics at this level of magnification. In other words, having the DevOps engineer sitting in the corner of the feature team is just a microcosm of the ops silo sitting inside the larger organization. And one of the ways we can see this self-similar behavior is at stand-up time. So we've got a lot of tasks here, and they're all tagged according to work stream or responsibility. And for a long time, I knew it was kind of an old agile thing that, oh, stand-ups are not status meetings, you know. But I'd never given really much thought to what the essential difference might be. And I think it's this. If you tag all of your tasks like this, you can guarantee that the developers are not going to be paying attention during the discussion of these DevOps tickets about storage and about encryption keys and vice versa. And nobody's going to be paying attention to the testing tasks about Selenium and control IDs, which are there every week. And so really, just like the embedded DevOps engineer is a microcosm of the ops silo in the wider organization, this stand-up meeting is a microcosm of that epic project status meeting with the cast of thousands and the big Gantt chart and the thing down the left, the work breakdown structure. So really, nothing has changed. But quite apart from this, what has changed is the world of infrastructure. Since much of this organizational was done, almost everything has changed. And I think this has an impact on how we need to think about designing our organizations in the future. So let's have a look at a picture of software development in the bad old days. So here are two chaps in 1980 doing a bit of software development. I think it is notable that there are two of them here. Pair programming is not as new as we think. And here's a picture of some people doing software development in 2020. So I think you'll agree that these two pictures are showing essentially the same activity. I mean, apart from a few details, like the clothing and the surroundings and so on, each of these pictures shows a pair of people staring at or reasoning about a screen full of text. But what about infrastructure and operations? So here's someone configuring a router much more recently than the chaps in the sweaters, as recently as 10 years ago. And here are two people configuring a router in 2020. I think you'll agree that unlike the first pair of images, these two images depict rather different activities requiring different skills and different experience. So in 2020, if software development looks like the picture on the left and router configuration looks like the picture on the right, do we need to have separate teams or sub-teams or individuals to do them? Well, let's suppose that we do. Well, what happens? Well, the DevOps people think, oh, it's great. We can use these new tools. We can do more infrastructure faster and faster and more reliably. And the developers think, oh, yeah, this is great. We can do our own infrastructure without having to talk to those idiots from ops. And of course, then we realize the developers have gone rogue and there's shadow IT. I love shadow IT all over the place, and the costs are out of control. So even though these two groups might be using similar or identical tools and techniques, the source control systems and CI/CD servers and the agile pantomime, even though these might be the same across both groups, the misaligned motivations are still present. And this is always going to be the case as long as the clown formation and the ARM templates and the Ansible playbooks and the Helm charts, as long as these remain the responsibility of a designated team or individual or individuals, we're never going to be able to bridge that gap. So if tools can't solve this problem, what are we going to do? Well, I think that this whole business of dev and ops collaboration has been kind of oversold, given how indistinguishable these activities have become. It makes less and less sense to manage them separately, and it makes more and more sense to talk about convergence rather than collaboration. So this is a variation on the earlier picture of our distributed DevOps team with the ops people embedded in the feature teams. So our new goal should be to get from here to here. This is the team of multi-skilled individuals, many of whom might be more or less T-shaped in the parlance, but really the point is that any of them should be able to contribute to any team deliverable in some kind of meaningful way. So how do we get from there to here? Well, we've been on this journey before, and it was with testing. So in 2020, I hope it's kind of uncontroversial to suggest that testers need to be able to write code and developers need to be able to write tests. And actually, the statement on this slide is from a testing maturity questionnaire from a book called Going Agile. And you know how these questionnaires work. You have to answer a bunch of true, false questions, and then you add up all the trues, and then that's your maturity score for testing. So this is a goal that we should be striving towards in our organization. But it isn't credible just because it's in a book. A bunch of companies have actually set out to do this, including Microsoft. So what did they do? Well, they merged together the development and testing functions. And what happened? Well, they said every sprint, the drift narrowed and the engineers picked up each other's skills, and they started small with maybe a feature scope and then getting larger. And eventually, one could not recognize an SDET, which is a test developer, or a SDE, which is a software developer, among the engineers. So great. And honestly, this is kind of the right thing to do. There's no point blowing a whistle and saying, right, as from tomorrow, everyone has to do everything in an agile manner. There's going to be this learning curve on both sides, and feature by feature or sprint by sprint seems a sensible way to proceed as any. However, there was something else that happened at Microsoft. You don't want this to be your ops teams, and you don't want this to be your company. And this is why it's so important to get this right. I've used this quotation a few times before. It seems to come and go from this page on their site, and maybe it kind of spoils the magic of the DevOps fairy tale. So regarding these infrastructure skills, I was being a bit disingenuous earlier. It isn't really a binary division between torque screwdrivers on the one hand and Terraform on the other hand. Again, it's a continuum largely populated by tools like these. And these tools are where a lot of the kind of manual and unrepeatable and untestable infrastructure work takes place. And this is something I've gradually changed my mind about over the years. I used to have this kind of internal analogy about these graphical tools for provisioning, like these, the AWS console or the earlier tools like WebMin or OpenView or the vCenter thing. And the analogy was this, that repetitively doing this same set of actions using these graphical tools was somehow a bit like programming, except that some parts of the program were running on a human, and maybe some part of the logic was stored in a spreadsheet in a team site. And it kind of reminded me of those drag and drop programming environments like Scratch, which might be familiar to those of you who are currently homeschooling. The analogy breaks down because, as we all know, there are a lot of activities other than programming that go into software development, such as version control and repeatability and testability and so on. And these are what's missing from the drag and drop configuration tools. So for those who are determined to remain chained to the mouse, I think there are still some roles to be done managing the infrastructure for the infrastructure, meaning the billing accounts, support agreements, the service contracts, and so on. But the number of these roles is greatly diminished, and really these are administrative rather than technical functions. I mean, I think we've all encountered the full stack developers who only do CSS, right? And we think that these people are ridiculous. But I think now in 2020, to be able to say, oh, I'm an infrastructure professional, I don't do coding, is just as ridiculous. So for the rest of our developers and our ops people, who we hope are the majority, how do we go about creating these converged teams? I had to put this in. I really did overhear this in the lift. I didn't get any context, but I can kind of guess what it was. So the challenge is to arrange our converged activities in such a way that they're palatable to all the team members. And I think the solutions are largely based in working practices with which we're all very familiar. So pair programming has a bunch of benefits: collective code ownership, which helps us reduce our reliance on key individuals. But it's even more important in this context, as we want to get away from this culture of dev tasks and ops tasks and DevOps tasks, so that all of our team members can own not only the application code, but also the infrastructure code that enables it. And thirdly, I think we're all aware of the business benefits of diversity, which stem from this finding that having a variety of lived experiences, whether these are social or cultural or educational, or in this case, professional, and that this enables our teams to build better products. And, I know that pair programming is hard, and I can offer a couple of mitigations, namely pair rotation and mob programming. Now, normally the purpose of pair rotation is about leveling up skills across the team, but in this instance, it's even more important from the developer's point of view, because it ensures that it's not always the same developer who has to pair with Nigel from networks. And mob programming, likewise, serves in both directions to disseminate knowledge throughout the team without singling out those people from the different background, from the ops background, because it's kind of easy for some developers to be dismissive of the ops people as the dinosaurs in the basement, but sometimes the dinosaurs do know things about networking or storage or security or other areas in which a lot of developers who are otherwise very competent sometimes turn out to be a bit sketchy. I wanted to touch briefly on testing and its benefits in this context of skill sharing. So anyone who's done much infrastructure code knows that these things can get quite unreadable quite quickly. And this depends in part, I think, on choice of tools, but that's another topic. In my experience, when we are presented with some indecipherable code and we're not sure what it does, the best way to gain an understanding of it is to attempt to write tests. And this, of course, is touched on in Michael Feather's book, which is as much of a London CD cliche as Conway's Law. And as a bonus, of course, we should get these infrastructure deployments that are a bit more reliable, maybe faster, more repeatable than before. And finally, on the question of ownership, we get shared ownership of code and tests for both our applications and our infrastructure. And again, this is something that is easier to put on a slide than it is to do in practice. And by definition, these infrastructure integration tests are tests with real dependencies and the usual integration testing headaches of complicated setup and complicated teardown. And these tests are so hard to write that they may not meet that cost benefit bar from a pure, let's say, TDD code design perspective. But in this case, they definitely do have some merit from a deepening understanding perspective of how our infrastructure code and our application code interact. And finally, I wanted to talk about this business of thin slices in the context of story definition or feature definition. And this is a pretty old notion, and it certainly dates from the period of n-tiered rather than n-serviced architectures. But I think the same thing still applies, which is that when we go to demonstrate a feature to the customer, we want to implement just enough business logic to make the UI work, and just enough persistence to make the business logic work, and just enough orchestration to make the business logic and the persistence work together. So the metaphor is that we deliver a little bit of each of these layers of the cake with every feature. And this should give us features that are independently valuable and consequently independently testable. So if we extend this model to include our infrastructure provisioning by including just enough infrastructure to make all these parts work together, we get early validation of the system architecture. And we might even save some money because we don't provision anything before we need it. If we've only done one of the methods of our web service, we might not need 20 instances to be able to test it meaningfully. But the most important of all, I think, is that we enable our infrastructure code to deliver value early at the same time as our features. And this is huge in terms of motivation to write it, motivation to test it, and motivation to deliver it. So by creating these converged teams, we enable our infrastructure code to deliver value early and with the same level of quality as our application code. So to wrap up, these attempts to bridge the gap by organizational tinkering or by adding more tools all fail to solve this problem of misaligned motivations. And the real story isn't collaboration anyway, it's convergence. Reorienting our existing teams to deliver these features and infrastructure together, I think, is difficult and not impossible. But as ever, the solutions lie in doing the things we already know how to do, but doing them more effectively. Thanks for listening. I look forward to talking during the open space.